First of all, thank you very much for joining this session. I'll start with my introduction first. My name is Tayyab Suhail. I'm a backend architect at Creative Chaos. I have over 9 years of industry experience, and I started my career in 2013 as a software engineer after completing my BS Computer Science from Punjab University College of Information Technology. And while I was working as an engineer, after a few years, I enrolled myself in a FAST MS program, which I completed in 2016. So over the last 9 years, I feel lucky that I worked with startups, mid-size and large-scale companies, and got opportunity to develop software applications for 100 fortune companies over the world, dealing with CPG retail industries. And I provided software solutions to them based on their business need. And most of the work that I have done is on Microsoft technology stack, where I develop applications in .NET Framework, .NET Core. I worked on Microsoft Azure Cloud, and of course Microsoft Office platform, and where I majorly focused on SharePoint Online, which is Office 365 product. So that's an introduction about myself, and I would like to now share my screen to talk about the topic for today's discussion. So I'm just going to launch my screen. Let me know when it's visible.
Someone has raised their hand. Um, yes. I mean, we haven't started yet, so I think we can take a question.
Mhm.
ADD. So, is there something you want to ask? Okay, I think it must have been a mistake. Maybe you can begin now, Tayyab.
Okay, great. So the title of today's topic is Simplifying Distributed Application Development. And just to set up the expectation from today's session, here is the agenda that we'll be covering. First of all, we will look into the introduction to set up the context of the session. Then we'll talk about the challenges of distributed application development. What are the common solutions to those problems? And then the proposed framework, which is distributed application runtime, DAPR. So most of the discussions would be around this framework, that how this will simplify the development experience while developing distributed apps. And of course, at the end of the session, I'll be showing demos of some of the components that I have built, and we'll be talking about in today's session. So there's a demo as well, and then we'll conclude and we'll take up questions if any. So that's the agenda. Let's start with the introduction. So we have witnessed evolution in software architectures, a significant shift from monolith to modular and scalable approaches. So uh, the traditional software architecture pattern that we have is monolith architecture pattern. you know and what happens in, you have one solution, you add different projects to it. You typically implement a layered system, like you have presentation layer, you have data access layer, business logic layer, and then you deploy it as a whole application, or in one unit, and in one unit. So this was basically the architecture that was being followed, and lots of applications were built on top of it. So, but with passage of time, the systems grew, and monolith architecture presented several challenges related to the coupling, scalability, and maintainability. So, with these challenges, the software practitioners, they sat, and this led to look into different opportunities to solve this problem. And that's how the microservices architecture came into existence. And since a microservices architecture, the concept was like, you have a bigger system, and you break this into smaller services, where each service is responsible for performing one thing, and each service has optimized data stores associated with it, and those services are independently deployable and scalable. So with with the microservices architecture, these problems were solved. But since microservices architecture offer lots of benefit of scalability and developing loosely coupled systems, but at the same time it presents some other challenges as well. Since your application is now decomposed into smaller services, so they may need to communicate with each other. Then definitely there is an inter-service communication between services. And similarly, since and if we take monolith architecture example, mostly we don't use this sort of communication. We have packages in place, we directly call them. But in this case, we make a call to the other services to communicate. And that's we have one challenge is inter-service communication. We will look into more details that what those challenges are, and how distributed application runtime solve those challenges. Other challenges are fault tolerance. So definitely, since we are developing small services where they will be collaborating, so we need to ensure that if one service is down, it should be fault tolerant. The other services should not be impacted. And since state management is also a challenge in microservices based applications. So this is an introduction. So just wanted to set up the expectation that what will be solving in this section, in this session. So I just added the diagrams to represent the architecture. So this is a typical monolith architecture where you have one database, and you have a unit of server app. All components are packaged into it and is communicating with database, and API is written on top of it that serves data to the different client apps. So this was the monolith architecture. And then we have microservices architecture, where the bigger service, or the giant application, is broken down into different services. So we have ordering, catalog, basket. These are just as examples. And then, of course, these services need to communicate with each other directly or indirectly. So this is a high-level overview of the microservices architecture. So now let's talk about the challenges. So the first challenge that we have is inter-service communication. So what are the challenges? For example, if one service needs to communicate with the other service, it has to be on a secure channel, right? And of course, the communication needs to be secure. And there should be retry patterns or circuit breaker patterns in place to ensure that the communication is fault tolerant and resilient. Then we have service discovery. Since these are small applications running, and if one application wants to talk to the another application, this should know the port on which it's running, which is not the ideal approach. So then definitely we need to have some sort of service discovery in place that will solve this problem to identify where the other services are running. Fault tolerant and resilience. So just like I talked about, that the services should be built in a way that they are fault tolerant and resilient. And configuration management, definitely, if you have a microservices architecture and you need to provide configuration to those services, then there should be a managed way through which you can share configurations between different applications. State management, if microservice wants to maintain the state, then definitely it needs a state management. Observability in distributed or microservices based application, since if you consider a feature, it's quite possible that your one feature needs to go through multiple services. So in that, if something goes wrong when the calls goes from second service to third service, then definitely we need to identify what happened. And in that case, we need some sort of tracing and observability in place to see what actually went wrong with that specific call, so that we can get to the root cause of the issue. So these were some challenges, and these are challenges are currently we see in distributed microbase applications. And the common solutions to these problems are like we install certificates to secure communication or connections between services, and and then we have traces and logs that solves the observability. We have, for example, open telemetry or other software in place that ensures that if we need to gather logs and traces, we can do that. Resilient state for long running states, retries and back off time periods. We implement retries and back off time periods through different libraries or like poly in our applications, and then message guarantee helps better decoupling. So these were some of the common solutions. So this was just to set up the context. Now let's look into the major topic that we will be looking into is DAPR, which is distributed application runtime. So if I read the first point, which is what is Dapper? So Dapper is APIs for building portable and reliable microservices, leverage industry best practice, and focus on your application's logic. So when I read this line, I can relate this with the arrival of cloud computing. Before that, if we wanted to deploy our application on servers, first of all, we needed to set them up. We needed to install all the softwares and ensure that the servers are properly configured before we deploy our applications to it. Then, with the arrival of cloud computing, this responsibility was delegated to the cloud platform. And the reason was that we delegate this responsibility to cloud providers. So we just focus on our application logic rather than looking into these sorts of issues that we can now, handle through, with few clicks and by setting few configurations. So that basically solved our problem for the infrastructure. Similarly, the way I see Dapper is it provides a set of APIs that we can use to build our microservices-based application that will ensure that the best practices are followed, and we will just need to focus on our application logic. So I'll like to draw your attention on this diagram that I have at the end. So we have three layers, which is application code, then we have Dapper, and the last we have cloud providers. So I would like to take this second layer out for a few minutes, and we'll talk about just these two layers, the application code and the cloud provider code. So let's say if I am developing a service either in .NET or in Python, and I want to write a message to, let's say, AWS SQS, then what would be the ideal implementation for this? If anyone would like to answer that, what should be the implementation steps? You can write it on the chat as well. All right. So let me talk about that. So basically, what will happen is if I'm implementing the service in .NET, what I'll do is I'll be looking for supporting packages that I can install on my service that will help me, communicating with AWS SQS instances. So for that, what I'll do is, first of all, I'll install the packages. I'll set up the boilerplate code where I'll set up the basic connections, and then I'll have to ensure that it follows the best practices. There are no memory leaks, connections are properly utilized and disposed. So in that case, I will provide the implementation. Now what happens is, since I have provided AWS SQS specific implementation in my code, and let's say that you go on a meeting and later you identify that AWS SQS may not be the right solution in our case, it will be Azure Service Bus. So in that case, what we'll have to do is we'll have to go back to the service. We'll have to look for the supporting package for the Azure Service Bus. We'll have to implement it. We'll have to write, the test cases to ensure that the coverage is up to the standard. And then we will remove the dependencies of AWS SQS from our project. So now you see that since with the change of cloud provider or cloud specific implementation, we have to make a change in our code, and that's the pain point that makes it more difficult during the development process, that these kind of changes, for that we'll have to make changes in our code base as well. Now let's put back this second layer Dapper in place and see what it offers. So Dapper is basically a distributed application runtime. So it says that in order to build your application, you basically need different building blocks. So for example, if your application wants to write message to the queue, you need to have a publish building block. If your application wants to maintain the state, you need to have a state management. If your application wants to communicate with the other service, it needs a service to service invocation building block. So that what Dapper provides, it provides you a set of building blocks and their components. So for example, state management is one building block provided by Dapper, and then it will have many components. So for example, it could be Redis, it could be Memcache. So these implementations will act as a components, and it work. And these implementations are provided through HTTP and gRPC based APIs by Dapper. So rather than providing cloud specific implementation in our application, what we will be doing is we will be utilizing this HTTP based API, which is a standard way of communicating with Dapper, and then Dapper will take care rest of the things for us. So for example, if I in that case, if I want to write some message to AWS SQS, I will consume the Dapper API and will mention in a configuration file that I want to use AWS SQS as part of my cloud provider, and that will automatically take care of this thing. And similarly, once we decide that we don't need to use AWS SQS and we want to use Azure Service Bus, in that case there is no need to change on the code level. We simply will go to the configuration file and we will change the configuration pointing from AWS SQS to Azure Service Bus. So that's one of the major advantage we can see, that it abstracts away the implementation detail and provide us an API through which we can communicate and get our job done. So the point number two, which is it simplify your code base, is basically you don't need to import cloud specific or specific libraries to your project. You can simply utilize HTTP based APIs to communicate with the components. And interchangeability, the third point, just like I explained example that at the start we started with AWS SQS, and later we decided to move towards Azure Service Bus. So it was just a matter of fact that we need to change the configuration, and that's it. No need to make any change in our code. Build vendor agnostic solutions. So just like we are not building any specific cloud providing solution, we are using Dapper that will help us to implement uh, vendor agnostic solutions, and it's not any language specific. Questions so far? Okay, so
Safdar has raised
okay,
his
sure, go ahead, Savdar.
Yeah, I have a question related to the services, like you mentioned SQS. So, what other services which we can refer to use for Dapper, like like Lambda service, and if we wrote something related to Lambda APIs, will it work with Azure functions as well? If you
Um,
used, Mhm.
so so to answer your question, so first thing is that um, it won't, since you have subscribed or written lambdas on SQS. So as soon as some message is written then it will trigger, right? And to answer your second question, that which components we can use. So if you go to Dapper's official site, which is dapper.io, they have listed down all the components in a building block. So for example, if state management, they have the list available where you can see whether I can use Redis, Memcache, and the other cloud specific implementation as well. And they also provide the YAML file that you just need to download and align it accordingly, and you're good to go to use that.
Okay. Thank you.
Tayyab, there are a few questions on the chat as well. I will read them for you.
Sure.
Is Dapper a framework or tool?
So it's basically a runtime. You can call it a framework, but it's not a tool.
Okay. And there's another question. Do we need to import packages for Dapper then instead of cloud native?
Hmm. So Dapper provides you the flexibility. You can import Dapper specific packages as well. The community, they are putting a lot of effort to ensure that they have SDKs available in different frameworks. For example, it's available for .NET, Python, Java. But if you are building in a in a framework where the SDK is not supported, then you can simply go and utilize HTTP based calls. I'll show you in the demo. I did not install any of the Dapper specific packages in my code yet. I am utilizing this runtime to get my job done.
Yeah. Thank you, Tayyab. I don't think there are any more questions.
Okay, thank you. So the thing is that how Dapper then basically solves this problem. So Dapper basically use sidecar pattern. Sidecar, consider it like a component um, or a container that runs along with your main service or primary service and helps you in it. So when I'll go towards the building blocks and I'll talk about service communication and state management, I have added some diagrams that will give you a better idea about how it works. But just wanted to add that it works on a sidecar pattern. It runs along with your microservice, and one microservice will have one sidecar. So adding benefits of Dapper sidecar. So the number one is automatic retries. Just like I mentioned that, imagine that if you are writing services, so you have microservice one, you have microservice two, and they are communicating with each other. So in order to ensure that the retries are implemented, you will provide specific implementation on both of the services, right? But you don't need to do that with Dapper sidecar. It is a part of the sidecar, and you just need to configure things, and you don't need to provide retries or other circuit breaker implementation explicitly. This will automatically be handled by Dapper sidecar, and encrypt with mutual TLS. So considering that we should have security to the bottom level, we Dapper ensures that the communication that happens between the sidecars of the services are encrypted and done through mutual TLS. We can of course configure access policies. Tracing and metrics are also captured over there, and it's language agnostic. So for example, if you have written a service in Python, you can use Dapper to spin up your sidecar instance. If you have written your service in .NET, Java, Go, it doesn't matter. You can still spin up the sidecar instance along with your service. So it's language agnostic. So the building blocks. So just like I was talking about at the start of the call, in order to build any application, you need specific building blocks. What Dapper provides some building blocks. So for example, state management, and in state management you can have components, you can have Redis, you can have Memcache. Then it also provides service to service invocation, where one service wants to communicate with the other service. Then it also provides a building block of publish and subscribe if you want to implement pub sub functionality. Input and output bindings are there. So for example, you don't need to poll, you can simply enable the input and output bindings. It provides you a secret building block that can be used to pull secrets. So for example, let's say we'll discuss all these in detail in later in the session, but just wanted to list this down, that these are basically the building blocks that Dapper provides. Let's look into the first building block that we have, which is service invocation diagram. So we have two services here, service A and service B. So you see that if service A wants to communicate with service B, the first thing that's happening is service A is talking to its own sidecar instance. After that, what this sidecar instance will do, this sidecar instance will look for the name resolution, which is multicast DNS in the case of Dapper. So for example, if service A wants to communicate with service B, service discovery needs to be happen. So that is something service invocation building block of Dapper automatically handles. So you make a call to the sidecar of service A, and then it looks for the name resolution, and will then, over the mutual TLS encryption, it will make a call to the service B sidecar. Service B sidecar will then talk to service B, will get the response, and will pass it to service A sidecar instance, and eventually this will be returned back to service A. So I have coded this example in for the demo that we will look into it probably at the end. So this is how it works. Now, how it does, it basically standardize your API calls between services. Now you can see that these service to service communication are secure and are done over mutual TLS. Otherwise, you'll have to, install some certificate sort of thing or configure things, to secure this communication channel. And of course, service discovery is something that is automatically being handled, and then we have tracing as well. So once service A makes a call to service B, all traces and logs are captured on this sidecar instance as well. So any question on this specific service invocation building block? Okay, so
There is a question
okay,
in the chat.
okay.
Does it affect communication latency when going through Dapper sidecars?
Yes, I think it's a good question, and I have added some details at the end of the slide as well. But let me address this question now. So yes, definitely, there is a communication overhead in this case when the communication happens between the sidecar instances. But I would like to add few things over here. The developers of Dapper and the community, they have put a lot of effort to ensure that this communication overhead is reduced. And one optimization I can say in this call is they are using gRPC based communication between sidecars. And gRPC is faster as compared to the HTTP based communication. So this is one of the optimization they have done. Lots of things they have already implemented to ensure that this latency is reduced. And they have also published some results on their official site that they performed load testing, and after that they came up with a number. And according to their website, they claim that the overall overhead between sidecar to sidecar communication is less than 2 millisecond, which can be ignored. But definitely it depends system to system. If you are building a system which requires high throughput and latency is a big problem, even you cannot compromise less than 2 milliseconds, then definitely that may not be the right choice for you. I hope it answers your question. Fatma, do we have any more questions, or should I move forward? Okay, I'll take that as no. So the next building block that we have is state management. So consider the similar example. If you want to maintain state in your application and you decide that you want to use Redis for this state management. So ideally what you'll be doing is you will be again importing packages in your application that will help you maintain a connection with Redis cache, and then you will uh, write to the Redis and will read from it. But in this state management block, you don't need to explicitly import packages on your application. As you can see, if we have a post URL and it's HTTP localhost 3500 v1 state store. So state store is something, it's basically a file where we have already defined that we want to use Redis as the state store. And when we make a post call to this sidecar instance with this JSON, then it will go and store it in the Redis cache. And later, if we decide that we don't want to continue with Redis, we will simply go to this state store and we'll change the source, and we don't need to make any changes in our code. I have coded an example for the state management as well, where I am writing some content or some payload to the Redis cache and then reading from it. So this is the state management block. As you can see that you don't need any specific packages in your application. So so in this screenshot I have attached, so this is how it looks like. What you need to do is you simply need to create a YAML files and you define it. So for example, this is the state store YAML file where it is defined that it's a component and the name is state store, and here I'm specifying that I want to use Redis, and then I'm providing the metadata information about where it is hosted and the credentials that are required to make a connection with Redis, and that's it. Later, if I decide that I don't want to use Redis, I simply need to make changes in this file, and that's it. No need to make any change in the code. So then we have another building block, which is secret management. The concept is similar here, that if you want to use any specific secret store, like you have Azure Key Vault, or if you have so you want to use that, you simply use the standard API, which is written over here, HTTP localhost 3500 with the sidecar port number. And then you pass the files through which it will read the configuration and will start communicating with it. And later, if you want to change, you can simply change this as well. So it's just to give you a quick overview, is you simply need to communicate with the REST APIs provided by the Dapper, and rest of the implementation will be taken care by the Dapper framework, the Dapper runtime. So you don't need to do that. These were some performance considerations that so there are other building blocks as well, but I just wanted to give you an overview of some of it and code it against them. Rest of things are available and will be done in a similar way. So some of the performance consideration that I would like to discuss. Just I think there was one question related to the performance, which is mentioned in point number 3. So which is so let's start with point number 1. So Dapper exposes a sidecar architecture to decouple your application from distributed application capabilities. Invoking a Dapper operation requires at least one out of process network call. Okay, as we have seen, it's a sidecar communication. And then Dapper team, they have significantly invested in performance, and they have a tremendous amount of engineering effort has gone into making Dapper efficient, and the overall overhead is close to 2 milliseconds per request, which can be ignored in most of the cases. So it's not like if a communication is happening between the sidecars and there is one additional call, so it will make a lot of impact. It's very minimal impact that you will have of this communication, but the benefits you'll get, are amazing. So that was about the performance consideration, and I would now like to go into the demo that I have built. So I hope my full screen is visible, right? I'm not just sharing the browser one. Okay. So I have these two services that I created. One, it's created on top of ASP.NET Core 6, and this is a catalog service, and the other one is the order service. And if I pull that diagram again, where I explained service to service communication. So let's consider this example. So we have service A and service B. In this case, let's say that we have this catalog service and we have this order service, and order service wants to communicate with catalog service to get information about the products. So what I have done is I have initiated the Dapper instance. So if I open this command prompt and I type dapper list, so this will list down all the sidecars running on my system. So this is related to order and it's running on 3502, and catalog is running on 3501. So these are basically the dapper ports, and these are the app ports on which the application is running. Now you can see that if I want to make a call from order to catalog, ideally I'll be making a call to the sidecar of orders to pass it to the catalog one. So if I open this order service and I go to this endpoint, here you can see that what I'm doing is I'm making an HTTP request, and here I am not using any package. I'm simply using a HTTP client, and you can see this port, which is 3502, and this is the port of order sidecar, and I'm currently on the orders microservice. So I am passing the request to the orders sidecar to invoke method of catalog service, which is products. Now the thing that we need to notice here is I did not mention where this catalog service is hosted, because this is the port of order sidecar. And just like I explained that service discovery is something that will be automatically taken care by the Dapper. So it will automatically figure out that catalog service is running on 3501 and will make a call to it and will return the data. And as soon as we get the data, we are simply returning it as part of the response. So if I open this Postman, and this is the endpoint, this is a protocol, it's running on localhost, and 35202 is basically the port on which order sidecar is running, and I am asking to invoke its orders method, which is this one. And when I make a call to this endpoint, this will eventually make a call to its own sidecar to forward this request to the catalog and get the products and return it. So if I hit this, you can see that I can see the list of products returned by the catalog service. And this is how the service to service communication worked. Any questions on this specific part?
Sir, I have a request, please.
Sure.
Um, Due to reason that I join currently, kindly revise in some simple words.
We will be sharing the recording of the entire thing. So you
Okay,
can,
thank you.
yeah, yeah, okay.
Okay, so I think if so, yeah, Fatma, do we have any question?
Abrar, yes, Abrar has raised hand.
जी मुझे सवाल था आपसे
जी
कि
sure.
डाकर और डेपर को अगर हम देखें डेपर में हम ये चीज है कि हम रेडिस यूज करना चाहिए या रेडिस की जगह पर कोई और चीज यूज करना चाहिए तो हम कॉन्फ़िगरेशन से ही उसको मैनेज कर सकते हैं, जबकि हमें अगर डॉकर यूज करना होता है तो हमें सारा सेटअप खुद कर मतलब कि वो डेवलप करना होता है। तो क्या हम अपाचे भी पेपर के साथ चला सकते हैं, मतलब कि इंजीनियरिंग हम चलाना चाहें या अपाचे?
अगर आपने किस पर्पस के लिए उसको रन करना है, लाइक वो कोई स्पेसिफिक टास्क परफॉर्म कर रहा होगा, अगर आपने लाइक राउटिंग करनी है, थोड़ा सा स्पेसिफिक यूज केस बता सकते हैं?
For the development of just like APIs development or any uh, website development.
हम्म बिल्कुल। देखें, ये किसी भी प्रोग्रामिंग लैंग्वेज हो या कोई भी आपका फ्रेमवर्क हो, ये उसके साथ चल सकती है। ठीक है, फॉर एग्जांपल आपके पास एक सर्विस गो में लिखी हुई है या डॉट नेट में लिखी हुई है, जावा में लिखी हुई है, डजेंट मैटर। ये आपकी उस सर्विस को एज ए साइड कार इंस्टेंस रन करेगी और रन करना शुरू करेगी। फॉर एग्जांपल अगर मैंने यहाँ पे 2 सर्विसेज डॉट नेट में बनाई हुई है ना, अगर एक सर्विस जो है ना वो पाइथन में भी होती है, गो में भी होती है, तो इसका प्रोसेस सेम रहना था, इससे इस पर कोई फर्क नहीं पड़ेगा। तो ये प्लेटफॉर्म स्पेसिफिक नहीं है। I hope this answers your question.
जी जी श्योर।
बट हाँ, जो ओवरहेड की आपने बात की, डेफिनेटली जो आप बता रहे थे कि वो एक्सप्लिसिटली सारी इम्प्लीमेंटेशन देनी पड़ती है, वो एक ओवरहेड है। और उसी से बचने के लिए जो है वो डैपर जो है ना, ये रन टाइम दिया गया है, जहाँ पे आप थोड़ी सी कन्फिग्रेशन चेंज करके अपनी चीज़ों को चेंज कर रहे होते हैं। और इमेजिन करें कि अगर आप ए बी टेस्टिंग करना चाह रहे हैं, आप अभी इनिशियल फेजेस में, जहाँ पे आप ये आइडेंटिफाई कर रहे हैं कि मेरी इस सर्विस के लिए कौन सी क्लाउड सर्विस ज़्यादा बेहतर रहेगी, तो आप ये भी कर सकते हैं कि आपको 2 स्पेसिफिक इम्प्लीमेंटेशन देकर उनके रिजल्ट्स गैदर करने की ज़रूरत नहीं है। आप सिंपल जो है वो 2 डिफरेंट सेट ऑफ कॉन्फ़िगरेशंस के साथ अपनी सर्विस को आप करें, और उनकी कम्युनिकेशन जो है वो सारी ट्रैक हो रही होगी आपकी ऑब्जर्वेबिलिटी में, और वहाँ से जाके आप उन दोनों के स्टैट्स को कंपेयर कर सकते हैं कि किस सर्विस में जो है ना वो परफॉर्मेंस आपको ज़्यादा बेहतर मिली है। सो वहाँ पर वो आपको एक क्विक डिसीजंस मेकिंग में भी जो है ना वो हेल्प आउट करेगी।
क्या हम डेपर को डॉकर की तरह इस्तेमाल कर सकते हैं?
डॉकर की तरह यानी कि एज ए कंटेनर बना के?
कंटेनर हो या तो मतलब कि एनीथिंग, मतलब कि कोई भी कन्फिग्रेशन हो जिसमें हमारा अपाचे और MySQL रेडिस हम उसमें चला सकें।
हाँ, देखिए, डॉकर को ना रन करने के ना 2 तरीके हैं जो कि उन्होंने अपनी ऑफिशियल साइट पे बताए हुए हैं। एक तो ये जो मैं यूज़ कर रहा हूँ, जो कि मैं अपने लोकल एनवायरनमेंट पे हूँ, ठीक है? तो ये लोकल एनवायरनमेंट सेटअप है। इसके अलावा आप इसको कुबरनेटिस के ऊपर भी होस्ट कर सकते हैं। उसकी पूरी जो कॉन्फ़िगरेशंस और वो जो डिटेलिंग है ना, वो सारी की सारी अवेलेबल है। तो आप उसको कुबरनेटिस पे भी होस्ट कर सकते हैं, और आप उसको जब अपने पास लोकली इंस्टेंस को भी रन कर सकते हैं।
ठीक है, थैंक यू।
No problem. All right, Fatima.
Rashid Ali has raised his hand.
Yep, go ahead, Rashid, please.
Okay, not specific to the part you're presenting right now, but my question is that other than latency and performance, do we have any other checkpoints where we should be, extra careful while opting for the dapper?
देखिए, इन माय ओपिनियन जो डैपर है ना, ठीक है, उसमें वो आपको डिफरेंट बिल्डिंग ब्लॉक्स ऑफर करता है। ठीक है, वो कम्युनिकेशन, सर्विस टू सर्विस कम्युनिकेशन का है, वो स्टेट मैनेजमेंट का है। सो उसने आपको कोई रिस्ट्रिक्ट नहीं करना कि अगर मैंने आपको लेट्स से 6 बिल्डिंग ब्लॉक्स दिए हैं तो आपने 6 के 6 यूज करने हैं। इसमें कोई रिस्ट्रिक्शन नहीं है। आपको अपने यूज केस को बहुत केयरफुली एनालिसिस करना चाहिए कि फॉर एग्जांपल अगर लेट्स से आप एक ऐसी चीज के साथ इंटीग्रेशन करना चाह रहे हैं जिसकी सपोर्ट अभी डैपर में नहीं दी, लाइक कोई ऐसी सर्विस लाइक रेडिस की है, किसी और कैश सर्विस की नहीं है, तो उस केस में और आपने वही यूज करनी है, तो आप उसमें स्टेट मैनेजमेंट वाले ब्लॉक को स्किप कर सकते हैं। लेकिन जो आप बाकी चीज़ें हैं, जैसे कि अगर आपके पास की वॉल्ट्स हैं, या आपके पास जो है वो सर्विस सर्विस इन्वोकेशन है, वो आप उनको यूज़ कर सकते हैं। तो इट्स नॉट लाइक कि एक चीज़ होती है ना कि फॉर एग्जांपल अगर आपने एक फ्रेमवर्क डॉट नेट फ्रेमवर्क है, तो अगर आपने कोई एप्लीकेशन उसमें बनानी है तो आप उसी के इकोसिस्टम पे रहते हो बनाते हैं, और वो फोर्स करता है कि आपने उसी के फ्रेमवर्क्स, उसी के लाइब्रेरीज को यूज करते हुए चीज़ों को बिल्ड करना है। लेकिन डैपर जो है वो ये रिस्ट्रिक्शन जो है ना इम्पोज नहीं करता, वो बिल्डिंग ब्लॉक्स ऑफर करता है। आप उनको बिल्डिंग ब्लॉक्स को यूज करते हुए अपनी एप्लीकेशन को बना सकते हैं।
Adnan Zafar has a question.
जी। अच्छा, मेरा क्वेश्चन रिलेटेड था मेमोरी यूटिलाइजेशन से, क्योंकि हम जब दो सर्विसेज को यूज़ करते हैं तो अगर उसमें सेम लाइब्रेरीज मल्टीपल टाइम्स लोड हो रही हैं तो उसमें हमारी मेमोरी की मैनेजमेंट इसमें किस तरह से होती है?
आपकी दो सर्विसेज हैं, ठीक है।
जी, जिसमें सिमिलर लाइब्रेरीज जो हैं वो यूज़ हो रही हैं और इस साइड कार की वजह से मुझे 2 मर्तबा उसको लोड करना पड़ता है, तो सिमिलर लाइब्रेरीज मेरे पास लोड हो रही हैं मल्टीपल टाइम्स, तो इससे क्या हमारी मेमोरी यूटिलाइजेशन इंक्रीज होगी?
देखिए, वो जहाँ पे आपका एक इंस्टेंस रन कर रहा है ना, उसको एक स्पेसिफिक स्पेस मिली हुई होगी, और जो आपका वो साइड कार है ना, वो आपके मेन कंटेनर के इंस्टेंस में रन कर रहा होता है, राइट। तो जितनी स्पेस आपकी उस प्राइमरी सर्विस के पास होगी, वो उतने ही यूटिलाइज कर रहा होगा। लेकिन इस केस में आपकी एक्स्ट्रा लाइब्रेरीज लोड नहीं हो रही होंगी, क्योंकि आप कोई स्पेसिफिक लाइब्रेरी इंपोर्ट नहीं कर रहे। आप अपनी कम्युनिकेशन जो है उसको HTTP के प्रोटोकॉल के बेस के ऊपर लेके चल रहे होंगे।
ओके, थैंक यू।
Any more questions before I go to the next demo? Right, I take that.
Wait, sorry, I was on mute. Tayyab,
Okay.
I was speaking. Yeah.
No problem.
Yeah. There is one in the chat. Does Sidecar work with event-based communication like Kafka or RabbitMQ, and how does it work with them?
Yes, it does. It does work with Kafka and RabbitMQ. I'll have to check if So just like you can consider, they on their official site they have listed down all the services through which it can communicate, and the developers and the community, they are very active and adding supports to this runtime, and enriching it with different components, like for example, if you're talking about Kafka, if you're talking about RabbitMQ. So if the RabbitMQ support is not available, I'm quite sure they would be working to add support to the Dapper runtime. But yeah, to answer your question, that's what Dapper provides. If you are using Kafka, you can use AWS SQS and the other queuing system as well, if the support is provided by the Dapper.
I don't think there are any more questions.
Okay.
Thank you. Oh, there is one. The one more again. Can you share this .NET pseudocode on GitHub later on?
Yeah, sure. I'll share it, but just I would like to draw your attention that there are some things which I don't appreciate, but I have done this just for the demo purpose. For example, like I have initiated this HTTP client in this method. This is not the best practice. You will have to, inject it through dependency injection, but don't consider this as a best practice. This is just to show you that how it works. I'll push it to the GitHub repository.
Thank you, Tayyab.
All right. I have quoted one more example, which is related to state management on the same order service. So what I have done is I have added another endpoint, which returns information about the specific order. So what it does, it takes an order ID, and as you can see that I have this URL, localhost 3600. This is the sidecar URL, and I am specifying state and state store. So I'm specifying that I want to read from this state store. I did not mention that I want to read it from Redis. I simply passed on the configuration and passing the order ID, and this will automatically take care. So if I can open my So here you can see that this is the Redis instance I have mentioned over here that I want to use. This is the state store component, and this is the service I want to use. And these are the credentials. So I've just mentioned it, and I am going to retrieve some orders from this state store, and I'll return it as part of the response. I have added few of the items to this Redis cache. I have posted 2 orders. So what I will do now is, let's say if I open this order service, since behind this specific endpoint, I am utilizing this Redis cache or state store. So if I pass that this is the order I want, so this will return me the price. So as you can see that if I pass this order ID, this has returned me the price because I have already pushed some sample data to this cache. And this is the thing I would like to highlight. I did not mention any of the specifics, store. I did not mention that I want to read it from Redis in the code, and later in future if I want to change it, I simply need to go to that configuration file and change it, and there is no need to change any thing in my code base, which is one of the, I would say, positive point about the Dapper. So that is the second demo part. Yeah, go ahead. Fatma, I think we do have some questions.
Yes,
Yes.
Rashid.
Okay, so I think that's the interesting part of this demonstration. So, like, what options do we have, for that cache storage? Can we, point this thing to a database as well, to Mongo SQL to get those state things from there as well?
Yes, definitely. So what you'll have to do is you'll have to go to their official site, right? There will be a list. They have listed down all the I'm sorry. They have listed down all the components that they are supporting. So you can change it to some other service they are supporting, and this will work as is.
Thank you, Tayyab.
So these were basically the uh, two building blocks I coded just to show you the essence or the benefits behind using Dapper. Of course, there are other building blocks as well that I would highly encourage you guys to go and look into it and try to code it yourself, so that you can get used to it. And just to let you know, the installation is not complex as far as the local dev machine setup is concerned. You simply go to their site, you install Dapper, and then, for example, if I open any of the service, if I kill this service, just to show you. Okay. So this is how we run a Dapper service. As you can see, Dapper run and then app ID. And we are passing this order. This is the name of the service, and then the resource path where you can look for the components configuration and on which Dapper port it will run. Sorry, on which app port the application is running and on which port Dapper will run. And just to show you one more thing, as you can see in this example, that in the REST URL, I am passing the version and then this invoke keyword and then the service name. So one question could come to mind that this will be a long URL, and what if you want to optimize this? So the one option that you can utilize is you can set the request header of this client by passing the app header ID, and you will have to pass the service name. So for example, if your intention is to send this request to the catalog service, you simply set the header to that specific header app ID to catalog, and after that you can simply remove this part and this part even, and you simply make a call to the products and it will route your request to the specific service. So you can do that as well. So this is how it runs. So let me quickly enter this. It will start, and now it has spin up a sidecar instance for this specific service, and now communication can be conducted on this. So that's all from my side with respect to this runtime and the demos. I will push this to the GitHub repository and will share the links with you. If you have any questions, you can ask now. But if you spend some time reading this and later if you have questions, you can reach out to me on LinkedIn and we can discuss your concerns as well.
Okay, so Tayyab, can I read out the questions?
Yeah, sure. Go ahead.
So before Rashid, I just have one question. Any best practice you would like to share about deployment microservices with Dapper?
So best practices would be that you need to ensure that you pass the configurations, or you keep your configurations in your solutions. For example, if you have three services, right, uh, on which you are using this Dapper, so you can set up specific folders where you will host your Dapper related YAML files, and then you pass that as a parameter, uh, just like I did, and initiate the Dapper instance. So this is related to how you deploy it on local instance. Of course, for the Kubernetes, it's a big game. We need to spend some time to and honestly speaking, I did not deploy it on the Kubernetes so yet. So I can only say with respect to the best practices for the local environment.
Okay, so first to address Moiz, there will be a recording shared for this session on our YouTube channel, and we will share it on LinkedIn. And if you've registered for the session on SurveyMonkey, then you will also get the link of the recording in about a couple of days. So Rashid has his hand raised. Rashid, please. Ahead.
Okay, a very high level question actually. So actually started this session with the comparison and the pros and cons of microservices and monolithic architecture. So where does Dapper lies in that equation? Towards the left or the right or somewhere in between, having all the good things of both the sides.
सो बेसिकली जब हमने सेशन स्टार्ट किया था, तो जब हमने कॉन्टेक्स्ट बिल्ड किया कि हमारे पास जो है वो मोनोलिथिक बेस्ड एप्लीकेशंस होती हैं, और फिर हम एक माइक्रो सर्विसेज बेस पर गए। फिर जैसे ही हम, क्योंकि मोनोलिथ के अंदर आपके पास चैलेंजेस थोड़े कम होते हैं, आपकी एक एप्लीकेशन के अंदर सारा कोड होता है और आपके पास लाइब्रेरीज होती हैं और आप उन सर्विसेज को डायरेक्ट कॉल कर रहे होते हैं और डेटा अपना मंगवा रहे होते हैं, जो भी आपने टास्क परफॉर्म करना है। लेकिन जब बात आती है डिस्ट्रीब्यूटेड सिस्टम्स की, लाइक जैसे माइक्रो सर्विसेज वन ऑफ देम, तो उस केस के अंदर आपके पास ये बहुत ज़्यादा चैलेंजेस आ जाते हैं। तो जो डैपर बेसिकली बना है, वो बना ही माइक्रो सर्विसेज बेस्ड एप्लीकेशंस के लिए। अगर आप उनकी साइट पर जाएंगे तो वहाँ पर वो बड़ा क्लियरली इसको लिखते हैं कि इट्स मेजरली डिजाइंड फॉर माइक्रो सर्विसेज बेस्ड एप्लीकेशंस।
Okay, Aurangzeb had raised his hand.
Hello, Tayyab, I have a question about that. Is there any other framework rather than Dapper available for microservices? Because I'm new in microservices.
Yes, there are a few I explored in the past, but those were not quite impressive. As far as my personal opinion is concerned, Steel2 is one of them. You can look into that as well.
So we have to use Dapper or for the microservices.
Not always. So for example, just like I mentioned that sometimes you develop, or you are asked to develop an application which cannot compromise on overheads. Even 2 millisecond overhead won't be acceptable. So in that case, Dapper is not the right choice. It depends on your specific scenario. I think there are different ways through on top of which you can build your microservices based applications as well. Like Service Fabric is one of them. So there are different ways to build a microservices based application. But Dapper, I usually look into different solutions to solve a specific problem, and then do a comparative analysis on it as well. So yeah, but as far as latency is concerned, if your requirement is that you cannot afford this, then Dapper is not the right choice.
Okay, thank you. Thank you.
Problem.
Okay.
Okay, so Rashid, are you going ahead?
Yes, just a small question, one last one. So do we have any cost factor while opting for Dapper? Because obviously microservices is already considered as an approach that do have involved cost factor already. Like with having Dapper on top of microservices, do we have any kind of concern? There would go a concern in cost access as well.
Not exactly. It's an open source framework. If you are talking that if you use this, runtime, so you'll have to pay extra for this. No, and just like it works as a on the sidecar principle, and you already have your instance up and running somewhere, and that machine will have some capacity, and in that capacity it will run. Uh, but I don't think there is a significant cost issue in this regard.
Okay, so like even if you would have to go for a kind of scalable, bigger level enterprise level system, even in that case.
Yes, in that case as well, this can be used.
Okay, so Rashid, does that answer your question?
Yeah, it does.
Okay. I have a few more in the chat as well. So Naman said first, I assume you are deploying on K8s cluster local. Do we need to change the liveliness and readiness probe in case if Dapper sidecar goes down? So basically, we need to make sure our app plus Dapper sidecar should both be running, right?
सो पहली जो क्वेश्चन है उसका जो है वो जवाब ये है कि आपको यहाँ पर के टेस्ट अपनी लोकल मशीन के ऊपर ज़रूरत नहीं है रन करने की. आपको सिर्फ जो है वो डॉकर डेस्कटॉप चाहिए, ठीक है. और आप जहाँ पर उसको, क्योंकि बाय डिफ़ॉल्ट जब आप डैपर को इनिशियलाइज करते हैं तो डैपर कुछ चीज़ें जैसे कि रेडिस कैश और इस तरह की चीज़ें वो आउट ऑफ द बॉक्स जो है वो सेटअप कर देती है. जैसे कि मैंने इंस्टेंस यूज़ किया रेडिस का, तो इट वाज ऑलरेडी क्रिएटेड एज पार्ट ऑफ द डैपर इनिशियलाइजेशन. जो दूसरा क्वेश्चन है आपका वो ये है कि बेसिकली समहाउ अगर आपका कोई एक इंस्टेंस जो है लेट्स से साइट का डाउन हो जाता है तो वो ऑटो हीलिंग वगैरह का क्या प्रोसेस होगा डैपर में, राइट? सो अगर आपका ये क्वेश्चन है तो आउट ऑफ द बॉक्स इसकी जो इनकी अगर आप डॉक्यूमेंटेशन पढ़ें डैपर की, तो वो ये बेसिकली रिलाई कर रहे होते हैं अंडरलाइंग ऑर्केस्ट्रेशन पे जो आप यूज़ कर रहे हैं. लाइक अगर आप KTS यूज़ कर रहे हैं तो डेफिनेटली आपकी अगर सर्विस क्रैश होती है तो आपने ऑटोमेटिक उसके ऊपर रिकवरी लगाई होती है तो वो दोबारा स्पिन अप हो जाती है. और लेट्स से कि अगर आपके पास सोल्यूशन नहीं है तो व्हाट यू कैन डू इज़ कि आप हेल्थ चेक्स इंप्लीमेंट कर सकते हैं, ठीक है. और जहां आपको लगे कि आपका इंस्टेंस जो है ना वो डाउन हो गया तो वहां पर फिर आपने जो अपना रिकवरी प्लान एग्जीक्यूट करना है वो आप कर सकते हैं. लेकिन आउट ऑफ द बॉक्स अगर वो क्रैश होता है तो डैपर उस चीज़ की रिस्पॉन्सिबिलिटी नहीं लेता कि वो उसको ऑटोमेटिकली अप भी कर देगा. ये वो रिलाई कर रहा होता है अंडरलाइंग ऑर्केस्ट्रेशन के ऊपर जहां पे वो रन कर रहा है.
Okay, next question. How do we share secret/environment variables across different microservice apps? I have seen a part of it at the start of the session. I am curious to know how we ensure that our app has the right access.
देखिए दो चीज़ें हैं. एक तो ये है कि एक्सेस की बात है तो वहाँ पर आपने जो है वो डिफरेंट सेक्शंस बनाए हुए होते हैं. आपके पास हर इन्वायरमेंट स्पेसिफिक कॉन्फ़िगरेशंस होती हैं, ठीक है. जब आप उनको लोड कर रहे होते हैं उस वक्त आपके पास डिफरेंट ऑप्शंस होती हैं कि आपने वो इन्वायरमेंट उठाना कहाँ से है. या तो आप उसको जो है वो अपने इन्वायरमेंट से भी उठा सकते हैं, या जब वो आपकी ऐप रन कर रही होती है उस वक्त भी आप पास कर रहे होते हैं. तो बेस्ड ऑन दैट आप वो स्पेसिफिक रिसोर्सेज मेंशन करके जो है ना वो पुल कर रहे होते हो सीक्रेट्स अपने. I hope it answers your question.
Zoha Shahzad. Yes.
Assalamualaikum. This is quite an interesting session. I'd like to thank you for that. So my question might be slightly unrelated. I'm currently studying interaction design, so it's focusing on like the user experience and user interface. So would you have any tips on how during the handover process, towards like a software engineer, a designer can, help simplify the development experience and make things better?
ओके सो यूजुअली इंडस्ट्री के अंदर जब भी कोई एक डिज़ाइन बन रहा होता है सो वहाँ पर एक बहुत अच्छी कोलैबोरेशन होनी चाहिए बिटवीन द डेवलपर्स एंड डिज़ाइनर्स. उसमें होता है कि जब आप एक डिज़ाइन बना रहे होते हैं तो डेफिनेटली उसको इम्प्लीमेंट करने की एक एफर्ट होती है. अगर आपने राइट कंपोनेंट्स जो हैं वो डिज़ाइन किए हैं तो इट विल बी इजी फॉर द डेवलपर्स टू इम्प्लीमेंट। और दूसरी इंपॉर्टेंट चीज़ ये होती है कि अगर आप एक एप्लीकेशन डिज़ाइन कर रहे हैं तो आपको एक कंसिस्टेंसी उसमें ज़रूर इंश्योर करनी चाहिए कि अगर मिसाल के तौर पे आप किसी जगह पर एक लिस्ट व्यू जो है ना शो कर रहे हैं, ठीक है, अगर आप उसके डिफरेंट वेरिएंट्स बहुत ज़्यादा स्टैंडर्ड वे में नहीं रखते हुए डिफरेंट जगहों के ऊपर यूज़ करेंगे तो वो डेवलपर्स के लिए थोड़ा मुश्किल होगा कि उनको डिफरेंट वर्जन उसके जो है ना वो क्रिएट करने पड़ेंगे। तो कोशिश करें जितनी कंसिस्टेंसी लेके आ सकती हैं ऐप के अंदर वो आए, ताकि एक कंपोनेंट जो डेवलपर बना लें वो उसको रीयूज कर सकें अनटिल अनलेस कोई एक बहुत स्पेसिफिक रिक्वायरमेंट है जहाँ पे उसको थोड़ा सा ट्यून करना है। तो आई वुड से कि कोलैबोरेशन इज़ वेरी इंपॉर्टेंट एंड जितने भी प्रोजेक्ट्स मैंने अपने एग्जीक्यूट किए हैं उसमें डिज़ाइन टीम और डेव टीम ये डेफिनेटली पहले सोल्यूशन डिस्कस करते हैं कि अगर हम इसको फॉर एग्जांपल ड्रॉर बना लें, इसको साइड पैनल बनाएं ना बनाएं, उससे ओवरऑल कम्प्लेक्सिटी के ऊपर क्या असर पड़ेगा। सो दिस इज़ व्हाट आई कैन से बेस्ड ऑन माय एक्सपीरियंस।
Okay, thank you so much.
वेलकम।
Does anyone else have any questions? Abrar. Yes.
मेरा सवाल ये था कि डेपर चलाने के लिए हमें रिसोर्सेज कितने चाहिए होते हैं, मतलब कि रिसोर्सेज कितने अवेलेबल हों इसको चलाने के लिए।
आप बात कर रहे हो कि अगर लोकल मशीन के ऊपर आपने इसको चलाना है तो
जी रैम प्रोसेसर मैं इसके लिए बात कर रहा हूँ।
ऑनेस्टली स्पीकिंग मैंने इतना इस परस्पेक्टिव से इसको गो थ्रू नहीं किया कि स्पेक्स क्या थी, लेकिन मैंने इसको 2-3 मशीन्स के ऊपर ट्राई किया था ताकि चेक करने के लिए कि इसकी क्या बिहेवियर है। तो एक मशीन जिसको मैं आपको बता सकता हूँ उसमें 4 GB रैम थी, उसके ऊपर वो चल रहा था। बट आई थिंक दिस इज समथिंग वी कैन कंफर्म इट फ्रॉम देयर ऑफिशियल साइट अबाउट द हार्डवेयर रिक्वायरमेंट्स।
थैंक यू।
Anyone else?
बेसिकली इसका एक कठिन सवाल था कि क्या इसके लिए इसको चलाने के लिए हमें WSL चाहिए होगा।
जी, आपको बेसिकली इसको डॉकर डेस्कटॉप जब आप रखेंगे तो आपको उसको इनेबल करना पड़ेगा क्योंकि जब वैसे तो उनकी अगर आप साइट पे जाए ना तो उन्होंने एक शॉर्ट कह लें, एक हैक कह लें, बताया हुआ है कि अगर इवन आपके पास डॉकर डेस्कटॉप नहीं है आप फिर भी इसको चला सकते हैं, लेकिन उन्होंने वहाँ पे रेकमेंड किया हुआ है कि ऐसा ना करें क्योंकि उसमें फिर आपके लिए जो सेटअप है ना वो बहुत चैलेंजिंग हो सकता है। तो उसके लिए आपको अपने लिनक्स बेस्ड जो है ना वो डॉकर डेस्कटॉप के इंस्टेंस को जो है ना सेट करना पड़ेगा।
थैंक यू।
वेलकम।
Karam Wali Khan has raised his hand. Yes, Karam, go ahead. You're on mute.
Hear me now?
I think by mistake हो गया।
Yes, yes.
Okay. Okay. So, first of all, Tayyab, thank you for such a nice session. I have a quick question. Like, how does basically Dapper handle retrying failed service invocations and manage errors? Like, can you explain what are the built-in retry policies, backup strategies, error handling mechanism?
जी बिल्कुल। सो this I think is a good question, and this is out of the box implemented by the Dapper sidecar, and that is one of the advantage that we have in Dapper. That, for example, if two services wants to communicate with each other, they'll have to implement retries on their sides to ensure that if something goes wrong, they can retry. But in the case of Dapper, it is automatically handled, and just to let you know इसमें configurations भी हैं। आप अपनी फाइल के अंदर जाके इस लेवल तक बता सकते हैं कि खाली एक तो होता है ना रीट्राई करना है, मैंने अब ये भी बता सकते हैं कि मैंने कितनी देर बाद रीट्राई करना है और क्या पॉलिसीज लगानी है कि इस लेवल के एरर्स को मैं रीट्राई करूं, इसको रीट्राई ना करूं। तो वो कन्फिग्रेशन YAML फाइल जो होती है ना, तो उसके बेस के अंदर आप अपनी कन्फिग्रेशंस डिफाइन कर सकते हैं, उसे वो कहते हैं resiliency.yaml। तो वो आप वहां जाके डिफाइन करें, उसमें आप बता दें कि आप किस तरह से इसको रीट्राई करवाना चाह रहे हैं। तो बेस्ड ऑन दैट जब वो साइड का टू साइड का कम्युनिकेशन होती है तो वो ऑटोमेटिकली उसमें रीट्राइज इंप्लीमेंट होते हैं।
All right. Thank you.
You're welcome.
Yes, Sardar.
Yeah, I was just thinking that के type ये जो टूल है या रन टाइम है it's more like conveniency for the development end, but it is more like overhead for as far as the administration has concerned, because आप एक तरफ तो एप्लीकेशन भी होस्ट कर रहे हैं, ऑन दी अदर हैंड आपको टाइपर का ये अपना रन टाइम भी होस्ट करना पड़ेगा, तो यू हैव टू मॉनिटर ऑल द थिंग्स लाइक योर एप्लीकेशन एंड दी डाइपर इज ऑल्सो कंज्यूमिंग मेमोरी सीपीयू यूटिलाइजेशन। तो उस एंड से भी फिर आपकी मॉनिटरिंग बढ़ जाएगी, सर्वर एडमिनिस्ट्रेशन बढ़ जाएंगी, और आपको ऑटो स्केलिंग वगैरह के ऊपर आपको मजीद फोकस करना पड़ेगा। तो इस हवाले से आपका क्या इनपुट है?
नहीं, बिल्कुल आपका पॉइंट बिल्कुल वैलिड है। अगर आप देखें तो वो ये इस चीज़ को क्लेम करते हैं कि वो डेवलपमेंट को सिंप्लीफाई कर देते हैं। ठीक है, फॉर एग्जांपल अगर आपको सॉरी, अगर आपको एक चीज़ का इंटीग्रेशन लिखने में टाइम लग रहा है तो वो उस पूरे डेवलपमेंट उन्होंने सिस्टम को सिंप्लीफाई कर दिया है, लेकिन डिप्लॉयमेंट के लिए थोड़े से ओवरहेड्स वगैरह होते हैं। लेकिन जस्ट लाइक जब आप इसको यूटिलाइज कर रहे हैं तो ये एक फैक्टर आपके दिमाग में होता है कि इट्स अ वन टाइम सेटअप, कि आपने एक दफ़ा इसको सेट कर लिया पूरी इस चीज़ को, उसके बाद फिर इसकी चीज़ें जो है ना वो ऑटोमेटिकली चलना शुरू हो जाएंगी। तो वो डिप्लॉयमेंट एंड के ऊपर आई एग्री कि वो थोड़ा सा एक कॉम्प्लेक्स पार्ट जो है ना वो होता है।
Abrar, do you have a question? You have your hand raised.
No, sorry, ये click हो गया.
Okay, Khura, please go ahead.
Yes, one more question extended to the point that raised by Safdar. So, Tayyab, what sort of consideration should we keep in mind while integrating Dapper into our existing, let's say, microservice ecosystem?
सो उसमें सबसे पहले तो आपको एनालिसिस रन करने की ज़रूरत है कि अगर आपके पास ऑलरेडी सर्विसेज बनी हुई हैं तो उसमें से किन किन जगहों के ऊपर आप इसको यूटिलाइज कर सकते हैं। तो आप उसके डिफरेंट बिल्डिंग ब्लॉक्स हैं, आप अपने सर्विसेज के बिल्डिंग ब्लॉक्स को देखें कि जहाँ पर आपको लगता है कि यहाँ पे एक ओवरहेड है और यहाँ पे हम इसको ऑप्टिमाइज करने की ज़रूरत है या चेंज करने की ज़रूरत है। ठीक है, आप उसको कंपैरिजन करते हैं और बेस्ड ऑन दैट आप वो बिल्डिंग ब्लॉक रिप्लेस करते हैं। सारी चीज़ एकदम रिप्लेस करना शायद पॉसिबल ना भी हो, इसीलिए बिल्डिंग ब्लॉक्स हैं। फॉर एग्जांपल अगर आपको लगता है कि मैं अपने एप्लीकेशन के अंदर स्टेट मैनेजमेंट एक तरीके से कर रहा हूँ, ठीक है, अगर मैं इसको यूज़ कर लूँ, ठीक है, तो आप खाली उसका स्टेट मैनेजमेंट का जो कंपोनेंट है, ये जो बिल्डिंग ब्लॉक है, आप उससे शुरू कर सकते हैं और आप अपनी एप्लीकेशन को विद पैसेज ऑफ टाइम ग्रेजुअली ब्लॉक्स बाय ब्लॉक्स जो है ना आप उसको इम्प्लीमेंट कर सकते हैं। और दूसरी चीज़ ये कि डैपर बेसिकली एक रन टाइम है, लेकिन वो आपको फोर्स नहीं करता कि अगर मैं आपको 6 या 7 बिल्डिंग ब्लॉक्स दे रहा हूँ तो आपने ये 6 7 ही यूज़ करने हैं। वो आपसे ये कहता है कि ये आपकी डेवलपमेंट को सिंप्लीफाई करेगा। ठीक है, ये बिल्डिंग ब्लॉक अगर आपको लगता है कि ज़्यादा हेल्पफुल है तो आप इसको यूज़ कर लें, और अगर किसी और जगह पे आपको लगता है कि आपकी रिक्वायरमेंट ऐसी है कि वो बिल्डिंग ब्लॉक आपको हेल्प नहीं करेगा, सो जस्ट लीव इट। तो इट आई वुड से कि आप अपनी सर्विस को एनालाइज करें और उसके बाद आप देखें कि आपको किस बिल्डिंग ब्लॉक से शुरू करना है, और विद पैसेज ऑफ टाइम आप उसको जो है ना माइग्रेट करें अगर जरूरत है तो।
ओके, थैंक यू।
वेलकम।
Anything else? Anyone else? Tayyab, do you have anything else to the presentation, or are we just at the Q&A part?
No, we're done. I'm done.
Okay, so if we don't have any more questions, I'm just sharing a link for the feedback of this session on the chat. So if you guys can fill that up, that would really help us improve future sessions. And so we would be really grateful to your feedback. Other than that, the recording will be sent to everyone who registered, and it will also be uploaded on our YouTube channel and all our social media channels. So you can keep an eye out for that. And Tayyab, thank you so much. This was really insightful. Thank you for taking on all the questions and preparing this wonderful presentation for us. So
thank you everyone for attending this session.
yep, thank you everyone. So